So welcome get 12s. So this is your lesson. Today we just have a very quick lesson. Okay, so we'll try to answer these two questions we have here. So we only got two questions, 13 and 17. So these are from paper 1 2024. So this question is from the topic so question 13 is from topic called variations. So variations is just a change. If something is varying, meaning it's changing with respect to time. So we have two types of variations. So there are two types of variations in grade 12 mathematics standard. So one is direct variation. Okay. Then number two is inverse variation. Okay. So how do they differ is very easy to know. So if I say x is direct proportion to y, meaning let me not use equals for the time being. Okay, let me just use some different values. Okay, so so we start with direct variation. So under direct variation, if we say x is direct proportion to y, we write like this. But of course there will be a constant of proportionality here. If we say z is direct proportional to k, so it will be z. We have a proportional constant, then we can have maybe w. So direct proportion, we just write like this. Okay, so this can be anything. So this is called a proportional constant. Proportional constant. Okay. Yeah, or constant of proportionality, same. Okay, so you need to incorporate k wherever you are dealing with variations. So when they say k or y is direct proportional to y, I mean x is direct proportional to y. So this is same as x is equals to k y. In simple terms, this one will be z is equals to k w. So you always have to put a k. This is for direct. They are in the same line. Okay, then let's just talk a bit about inverse. So inverse variation. So for inverse variation, if we say x varies inversely or is inverse proportional to y, we write x to be k over y. So inverse, it means 1 over this value. So in other terms, we can write it like this: x, then you write k, then y, inverse of y, meaning y is 1 over y, inverse. So you can see these are not directly proportional. Now it's over instead of writing y here. So x is now equal to k, because k multiplied by 1 is just k over y. So there are times they'll tell you x varies inversely proportional to square root of y, meaning y will be under square root. X varies inverse proportional to square of y, meaning y is squared. So you follow according to the question. So let's say z varies inverse to the square root of x. So x will be like this, meaning in a simple form, z equals to k over square root of x. Okay, so inverse, you are dividing the k, but in direct proportion, you are multiplying the k to the variable. Okay, so that's basically what this topic is all about. So now let's dive directly into the question. Okay, so I'll paste the question here. Okay, so this is 13. So now we have to get to solution. Okay, so 13, given that y varies direct proportion to x. Okay, so you are told y varies direct proportion. So first you put k, don't forget the k, constant of proportionality, varies directly as x. So directly as x, meaning it's directly varied to x, and inversely as, so the question continues, and inversely as the square of z. Okay, and inversely, so z will come here, z square. So y, meaning this is the same as y equal to kx over z squared. So y is directly to x. X is here. So from the illustration above, x is direct, so x is on top. Then z is inverse, z is at the bottom here. Okay. Then we are told y equal to 4. Okay. X equal to 8. Okay. Then z equal to 2. Then question part A, we are finding k. So k, this k. How do you find k? So you write y equal to kx over z squared. For those others who are very familiar with mathematics, you can make k subject to the formula. So this is over 1. Cross multiply. So this multiplied by this to be kx. 1 multiplied by kx equal to y multiplied by z squared, it will be yz squared. Okay, so we want k to be the subject. So we are revising as well. Okay, over x. So we're dividing by x both sides. Then k is equals to y z squared over x. Okay. So now we put the values. We've been given the values for y. What is y? Y is 4. Multiplied by z. Z is 2. So 2 squared. Over x. X is 8. Okay. So continue. This is 4. 2 squared. 2 squared is 2 by 2. If it was 3, by another 2. If it was power 4, by another 2. Okay. So hope you remember from our previous class on indices. Okay. You don't have to have a problem by now, since we've talked about indices multiple occasions. Okay. So now we just have to simplify. So 2 squared will be okay, 2 squared. So okay, so we are here. Okay, so sorry for that. So 2 squared, it will be 4. So this will be 4 over 8. So 4 by 4, which is 16. Okay, over 8. So 16. What's 8 divided by 16? So 8 plus 8 is 16, so this is 2. So we know k is equals to what? 2. Okay, so we've answered part A. Part B. So part B, we are told to calculate the value of y when x is 18, z is 3. So x is 18 and z is 3. So you need to be very careful, because k, if you get k wrong, meaning you get everything wrong here, then k is 2. We've already solved for k. So y equal to kx over z squared. Okay, that's our equation from here. This is our equation here. So now we're finding y, okay? So just put the values. K is 2 multiplied by x is 18 over z is what? 3 squared. So this is not 3 times 2, it's 3 by 3. Okay, so you have 2 by 18 by 9. Okay, so you can divide here. 9 goes into 18. Wait a minute. Okay, yeah. I thought it was 16. Okay, so here 1, here 2. 2 by 2, which is 4. Okay, so y is equals to 4. Very simple and straightforward. So we go to part C. So part C is equation. This software is misbehaving. Okay, so part C, I can't seem to see part C. Okay. Okay. Part C, find the value of z when x is 25 and y is 2. So x is 25, y is 2. So x is 25 and y is 2. So k is also equals to 2. So you need to know. Here is just to know if it's varying direct, it's numerator. It's multiplied by k directly. If it's inverse, it is at the denominator. Okay, so you write the equation y equal to k x over z squared. So we are finding z here. We have x, we have y, we have k. So you can make z the subject of the formula if you want, or you can substitute the values and solve directly. So the best way is to make the z subject of the formula, so that you should be remembering how to make subject of the formula. So this multiplied by this, it will be kx. Y multiplied by z, it will be y z squared. So we want z, so we divide by y, divide by y. Okay, so this and this will cancel. Z squared equals to kx over y. So how do we remove the square? We take a square root. So we take a square root. So when you take a square root, you add the plus or minus. That's how we do that. So this and this you cancel out. Okay, meaning z is equals to plus or minus square root of kx over y. Then we put the values now, since we have everything. Z equals to plus or minus square root. So what's k? K is 2. Okay, what is x? X we've been given is 25. Okay, 25 over y. What is y? Y we've been given to be 2. Okay, so this is 2. So this and this will cancel out. So z equal to plus or minus 25. Okay, so we know the square root of 25. Z equal to plus or minus square root of 25 is 5. So meaning z is equals to positive 5 or z equals to negative 5. So remember, every time you are taking a square root, you have to remember the plus and minus. So remember, every time you're taking a square root, you write plus and minus in front of it. You can have two sets of answers. So z is plus 5 or negative 5. Okay, so this is about variations. So hope you guys have understood what I've explained about variations. Then the bonus question. Okay, so for a bonus question, so I just wanted to teach variations today, but I think we have some time to spare. Okay. Okay. So now we revise functions a bit. So functions. I wonder why this software keeps on doing this. Okay. Let's see. Okay, so sorry for that. Continue. So now we need to revise functions. So functions is very important to learn about functions because they are everywhere. So everywhere you go, you find functions. There is no way you can avoid them. Okay, so there are a lot of functions, there are a lot of types of functions, but basically okay, so this program seems to still okay, so try to copy this one. See if you have a challenge, you have to change the application. Okay, so I think we're okay now. Okay, so functions. So you have two functions here in question 17. You have g and f. So you've been given two sets of functions. They are both functions of x. Okay, so I think it's here now. So we have f of x. So f of x, which is equals to 3x minus 4. Okay, then we have g of x equal to x plus 1 over 3. Okay, so the first question, there are two functions here which we have to understand. There are how many functions? Two functions. One is f of x. So the one function is f. We know f is varying with x or is related. Let me say f is a function of x. Okay, and also g is also a function of x. Okay, so we have f function of x, g also as a function of x. So part A, we are told to find f inverse of x. So when you see this power, it means inverse. So at times they'll say find the inverse of f of x. So they can phrase it like find the inverse. Find the inverse of f of x. Or in short, they'll just write find these are the same. It's the same terminology. So if they say inverse, they write power negative 1, it's the same thing. So first of all, we'll write f of x is 3x minus 4. Okay. So if they say inverse, what they want is you make this the subject of the formula. You make the variable here. So it could be y, it could be a. You make this variable subject of the formula. So we replace this value here. We don't want this value. To make our equation easy, we'll substitute this f of x with any variable. You can pick z, but most books they use y. So you can just remove this function, replace it with y, then write this side the same way. So we want to make this x subject of the formula. So we take the for this side. So let me just rewrite it like this, then equal to y. It's the same thing. This is here, this is here. It's the same. Nothing has changed here. Okay. So we'll take this y, this 4, this side. Or what other people call adding both sides by 4. Okay, but we just like taking it to the other side anyway. So you say 3x equal to y. So when we take this is a negative, when it comes this side it will be a positive 4. So we want x to be alone, so we divide by 3, then here divide by 3. So x equals to y plus 4 over 3. So when you just make x subject of the formula, meaning this is the inverse. So you remove now this x, you write the initial value you've been asked. That's the question you've been asked. So when you make x subject of the formula, meaning you are done, you found the inverse. Then here we didn't have y here. So here we put x back plus 4 over 3. So I hope you guys have understand this question. So first of all, you substitute f of x with it. So let me just quickly go through. F of x, it was like this, 3x minus 4. So you remove this one and write y. So y equals to 3x minus 4. Then make this subject of the formula. Okay? So you take the 4 this side. So it will be y plus 4 equal to 3x. Then you want x to be alone, so you divide by 3, divide by 3. So this will cancel. X is equals to y plus 4 over 3. So when you reach here, I've said this is the same as the inverse when you just express x in terms of other variables. So meaning your inverse is, you can't leave y here because initially we didn't have y. This was just a guess variable to help us solve. Okay, so this function is in terms of x. So you put x here. You can't leave y because y was initially not there. It was just conceptual to make our solving easy. So this is your inverse. Okay, so let's go to part B. So part B, I think let me just use weight. This one is not behaving rightly. Okay, so sorry about that. Okay, so okay, so it's the same. Let's just let's use weight. Yeah, let's just use weight. It's behaving. Okay, So we'll just continue from here. We'll just put the question here. It's taking years again. F. So here it's a little bit tricky, which you have to know which equation is at the beginning. Which equation is at the beginning? That's what you should bear in mind. So G is appearing first, then F. So what this means is, first you write the equation for G. G of x equal to x plus 1 over 3. So what this means is, in this equation for G of x, where there is x, you substitute the equation of f. So G is at the beginning, so you consider the equation at the beginning. So if there was f here and G here, so we could have written the equation for f of x first, 3x minus 4. So if it was, let's say, f g of x, so we could have first write, because f is appearing first, we could have written this equation first. Then where there is x, we substitute the equation for g of x. This is what it means. So g of f of x, what it means is, so write g of x. So where there is x here, we put the equation for f of x. So where there is x, we write 3x minus 4. This is the equation for f of x. So where there is x, we are substituting f of x. Then here, plus 1 over 3. Okay. So g f of x is equals to, so there is 3x minus 4 plus 1 over 3. Okay, so negative 4 plus 1 is negative 3. So we have 3x minus 3 over 3. So you can factor out the 3 on top. So g f of x equal to, so on top you take out the 3 to be x minus 1 over 3. So this and this will cancel. So you just remain with x minus 1. So g f of x is equals to x minus 1. Okay, so I'll repeat. G is at the beginning. So you write the equation for G. Then where there is x in the equation for G, substitute equation for f of x. Okay, so if let me change the equation now. It's not part of this. The answer for our part B is this, but let me write f g of x. So how do we solve this one? So first of all, we write 3x minus 4. Okay, this is f of x. Let me check. Okay, so f of x is, okay, 3x minus 4. Okay, so this, now here where there is x, this is the equation for f of x because it's appearing at the beginning. So this is the equation for f of x. Then now where there is x, we substitute the equation for g of x. So this could have been 3, open bracket. Then what's g of x? G of x is what? X plus 1 over 3. Then minus 4. This minus 4 minus 4. So this will cancel out. Okay. This could have been x plus 1 minus 4. This could have been x minus 3. Positive 1, negative 4, it will be this. So please bear in mind, when I write like this, first begin with the equation here, then where there is x, substitute the equation for this function which is here. So we've solved g of x. Our question was here, so we solved. This is our part B. This is our part B. We've solved part B. This is g of f of x. Okay, so next, g of x of negative 3. Okay, so see g of f of negative 3. Try to look for an eraser. This looks dirty. Okay. Okay. So we know g of x. We've already found this equation. Okay, which is x minus 1. So when they say g f of negative 3, they mean where there is x now, this equation we've solved. Where there is x, we substitute negative 3. So write negative 3 minus 1. So g f negative 3 equal to negative 3, negative 1, negative 4. Okay, so these are your answers. These are your answers. So little bit of takeaways. So we've discussed variations. So I said if x varies direct proportion, it's the same as k direct proportional to y. Direct. X varies inversely proportional to y is k over y, and k is a constant of proportionality. Okay, this is inverse. Then for functions, I've said f g of x, meaning you consider the equation for f. So you write the equation for f, then where there is x in that equation, you replace the equation for g. When you write g f of x, you're considering the equation for g. Then where there is x, replace the function f. Okay, so thank you so much for your continuous supporting my page. So you guys continue watching, invite your friends, yeah, share my videos. Thank you.